Welcome to Aryabhat Center for Theoretical Physics. This is another video. This is lecture number 5th in this series called Calculus, and in this video I am going to explain integration by substitution. How using integration by substitution we can solve any integral. So suppose ux is a continuous derivative in the interval CD, open interval CD, such that value of u at point CD is AB, and assume that fx is a function which is continuous in the interval AB, and capital Fx is antiderivative of this Fx and is also continuous in this interval AB. Then we can say that f of ux of derivative of ux dx is equal to f ux plus c in the interval CD, or integration from c to d in the interval CD, f of ux x dx is equal to fb db, where integration is from u to ud. Now we can use this to solve this integral I is equal to 2x plus 1 to the power 9 dx. Now if we assume that u is equal to 2x plus 1, and if we integrate du is equal to 2 dx, it means dx is equal to du by 2. It means now we substitute this one and this one into this, and this integral will become u to the power 9 du by 2, which is nothing but a half u to the power 10 divided by 10 plus some constant c. Now we put back the u, which is 2x plus 1 to the power 10 divided by 10 plus c. So this is the value of this integral. This is how we can solve any integral with the help of substitution method. Let us consider another problem. Sin 2x dx, I is equal to sin 2x dx. If we assume e is equal to sin 2x, and if we differentiate this u with respect to x, we will get du is equal to if we assume e is equal to 2x, then du is equal to 2 dx. Now substitute both into this, it will become sin u divided by 2 du, or I is equal to half sin u du, and integral of sin u is minus cos u. So minus half cos u plus some constant c, or minus cos 2x plus c. This is the example of integration by substitution. Take another problem. 2x plus 1 x square plus x plus 1 to the power 5 dx. Now we can use integration by substitution to solve this problem. First of all, we assume that this term x square plus x plus 1 is z or u. We can assume anything. X square plus x plus 1 is equal to u. Now, if we differentiate this u with respect to x, so we will get du by dx is equal to 2x plus 1. It means this term is du by dx and this term is d5, u5 and dx. Or I is equal to u to the power 5 du, or I is equal to u to the power 6 divided by 6 plus constant. It means the solution of this integral is x square plus x plus 1 plus to the power 5 divided by 6 plus constant c. This is the solution of this integral. Again, we take another integral root to the root fx minus 3 dx. We assume e is equal to 5x minus 3 or du is equal to 5 dx. We plug this into this equation, you will get root u du divided by 5, and the integration of root u is u to the power 3 by 2, 2 by 3 plus c. It means 2 by 15 u 3 by 2 plus c, or I is equal to 15. We plug back into this equation, we will get 3 by 2 plus c. This is the solution of this integral. So these are the few examples of integration by substitution. So these are the few problems of integration by substitution. In the next video, we will talk about integral using trigonometric function.